Hey, I'm Joel. This is a video tutorial on Roland's Zenology Pro software synth. I'm going to be talking about MIDI mapping, automation, and the matrix control section here, which basically allows each partial to have one parameter, one control, modulate up to 4 others, either in a positive or negative value. Each partial has its own matrix control section attached to it, which is pretty cool. So MIDI mapping to start with. So these 5 master controls here, if we're using Ableton or any other DAW, but if we're using Ableton, we have the automation enabled. If we just click one of these parameters here, we can see the automation lane moving in the background. So we can automate that simply by clicking like so, and we can see that parameter changing. Or we can, down the bottom here, in our third-party plugin, which is Zenology Pro, we click that drop-down box, hit configure, and then click the parameter, move a parameter, and then we'll add it to the plugin down the bottom. So then we can just click that knob, right-click, show automation, and then automate it from there, and we'll see it corresponding here and here. Let's just change the oscillator to a saw wave. Okay, so the other controls in Zenology Pro aren't quite as straightforward to automate at the time of filming this video. Hopefully this is something they fix. Let's just reset these to default. So the way to automate other controls is if you have a hardware controller like I do. I have a Novation circuit tracks attached by USB. If I right click a parameter that I want to automate, I can hit Learn MIDI CC and then just move a knob on my MIDI controller, and then if we right click it again, we can see that it's assigned to number 28. Each controller has its own CC values attached to the knobs and faders and aftertouch and pitch bend and all that stuff. But yeah, that particular knob was CC value 28. And let's just, I'll right click this fat control here, Learn MIDI CC, and I'll move a different knob on my controller. And then now I can automate those two simultaneously. Now we know that 28 is the pulse width and 85 is the fat. So now if we open a MIDI clip in Ableton, unfortunately with Zenology Pro, I can't figure out how to add the parameters automation to the automation lane, but they're assigned to the actual MIDI clip itself. So not really a massive downside. It just means that you have to open up the clip to see the automation rather than seeing it in the automation lane. So if we have the clip open by double clicking it, down the bottom here, we hit MIDI control in the envelope section, make sure that's switched on. And then we can see, 28? So 28 here. If I move number 28, we can see that changing there, or I could just move the control again. And then this one here is MIDI CC 85. So if we go to MIDI CC value 85, if we automate that, we can see that corresponding here. So again, a bit of a pain that you can't see it in the automation lane, but there is a way to automate it, either using the hardware controls, and I can just record those changes. And we can see that that's added them down here, 85 for the fat control and 28 for the pulse width control. I hope that all makes sense. So let's say you don't have a hardware controller. So what you can do is you can right click the value you want to automate, Learn MIDI CC, and then move one of these lines. So let's say you want the pulse width modulation on number 14. So if I automate that there now, once I play it, Zenology Pro is going to register that CC value having moved after I've right clicked and learned. So now when I play it, now that automation line down here, number 14, if we right click it, we can see it's attached to number 14. Yeah, I hope that makes sense. Just right click, Learn MIDI CC, either move a controller or move a knob on your controller, or just automate one of these lines and press play, and it will remember which CC value is being modulated down here, and that will attach itself to that control. So you have essentially 128 or 120, CC values to automate. That's MIDI mapping. Pretty straightforward. Just play around with it, rewatch, rewind, all that stuff. Alright, so now we have the range control section here. There's one for each partial. They won't look any different now because I haven't made any changes, but if I set this to that there, and then I set the second one to that there, you can see down here when I change the partial, we can see that changing. So I'm just going to give you the rundown now. I'm just going to read basically straight out of the manual. This part here is the source, and these 4 are the destination, and you've got 4 of them in total, as you can see, per partial. So here's all your CC values for the different MIDI messages. This control section here, so if you're using a hardware controller, the bend is the pitch bend wheel on the controller. AFT is aftertouch feature. Some of the slightly higher end keyboards would have the aftertouch. So that's when you push your key and then you push it down a little bit further, and you can change different settings. You can alter the MIDI messages by pressing that aftertouch. System control 1 to 4. So by default, system control 1 is CC01. System control 2 is aftertouch. System control 3 is CC02. And system control 4 is CC04. Alright, so velocity is the velocity of like the pressure that you press the key with or the pad with. Key follow is the keyboard position with C4 as 0. So C4 being the default, being right in the middle. And as you go up from C4, you can have a parameter, a MIDI message change as it goes up. So you could say the higher you are on the keyboard, the longer the release will be, or the more open the filter cutoff would be, for instance. Or if you go below C4, you could have it close the filter or reduce the release or the sustain or whatever you wanted. You could use the octave ranges on the keyboard to behave differently based on which octave you're playing in. Tempo is the tempo specified by the DAW, so you can have the tempo controlling the different effects. So if you have a song that changes tempo, either gradually or instantly, you can have that tempo change different parameters. LFO1 is obviously LFO1, LFO2 is LFO2 on the partial you have selected. Pitch envelope is in the pitch envelope section. You can have the pitch envelope modulate up to 4 different parameters, and the filter envelope, same thing, and amp envelope, same thing. So if you had your pitch envelope set in a way that you liked it, that you could then use those same settings to change other settings. So now that's the sources. So now to the destination. Off means that the matrix control will not be used. PCH changes the pitch. Cut changes the cutoff frequency. Res changes the resonance, so you can have something control the amount of resonance attached to it. Lev is changing the volume level. Pan is changing the pan. So CHO is chorus, but it doesn't work in this product by itself, and same with Rev. Rev is reverb. They don't work by standalone in Zenology Pro. If you're using hardware or ZenBeats software, then you can have this parameter control the hardware or the ZenBeats software's settings. Pit/LFO1, Pit LFO2. You can send the pitch to LFO1 or LFO2. These are sending the filter to LFO1 or LFO2. Amp is sending the amplitude or the volume or level to LFO1 and 2. Pan LFO1 and 2 sending the pan. So the LFO1 rate or LFO2 rate. In the manual it says the speed will not change if the LFO rate is set to note. So if you've got it set to a note value based on the tempo, this can't be controlled in this section. It's only if it's on free rate. Pit attack changes the time 1 of the pitch envelope. I'll explain that in a sec. Pit decay changes the time 2 and 3 of the pitch envelope, and pit release changes time 4 of the pitch envelope. So if we open the pitch here and we have the envelope, we can see when we move our mouse over the different nodes here, we can see in the top left, so it says T1, that's time 1, T2, time 2, T3 is time 3, T4 is time 4. So that time 4 is the release, time 2 and 3 is the decay, and time 1 is the attack. So essentially with these controls here, so we can change the pitch, envelope, attack, decay, and release. So the level 1, level 2 and 3, and level 4. Same with the filter. So filter attack level 1, filter decay level 2 and 3, filter release level 4. And same with the amplitude envelope. The amp attack is level 1, decay is level 2 and 3, and amp release is level 4. So PMT in the manual it says, if the matrix control is used to split partials, set the PMT velocity control to off. If the matrix control is used to split partials, we recommend setting the sends 1 to 4 to plus 63. Selecting the lower value may prevent switching of the partials. Furthermore, if you want to reverse the effect, set the value to minus 63. And then it's got a second bullet point. If you want to use a matrix control to switch smoothly between partials, use the velocity fade lower and velocity fade upper. So the PMT section here, I'm not really sure how it works, but it's used to split the partials across the keyboard. So I'm pretty sure, I'll correct this in another video once I understand it, that the PMT here has something to do with the range control section here, like splitting the keyboard up or splitting the partials up along the keyboard. FXM section changes the depth of frequency modulation produced by FXM. So I think that's something to do with the cross modulation here, but I'm really not sure about that one. Sorry about that. The MFX control 1, 2, 3, and then if we go into this second section, 4 here. So in the master effects section, we can see we've got 4 different controls here. So let's just hit a chorus, for instance. We can have one of the different controls here, or CC value control one of these, in this case 2 effects. We can have it change the rate and in hertz and the balance. So if we close that master effects section, zoom in again. So those 4 master effects controls there are those 4 that we had down here in master effects. So you can modulate them independently or together using this matrix control. Moving forward, the PW applies changes to the pulse width. So if we go back to the oscillator here, it'll make changes to the pulse width there. The next one down is pulse width modulation and FAT. So they're obviously all 3 of those: pulse width modulation, depth, and FAT. The next one here is the cross mod. This setting is only valid for the carrier partial 1 or 3, and applies change to the cross mod 1 to 2 depth or cross mod 3 to 4 depth. So if you know more about synthesis than I do, you would know what the cross modulation would do, and partial 1 being the carrier of 2, partial 3 being the carrier of 4. So this setting here allows us to change the depth of the cross modulation. So this one here, X mod, yep. LFO step 1 and LFO step 2. So the LFO has a step sequencer in it to control the LFO and how it behaves with the tempo and the timing. Out of the manual it says this is valid if the LFO1/LFO2 waveform is in step. Yeah, I don't really understand how that one works, but yeah, feel free to play around with that and let me know downstairs there. This is Supersaw detune here. So if we go into our oscillator and select a Supersaw, we have this feature here. The pitch depth, that changes the depth of the pitch envelope, and the filter depth changes the depth of the filter envelope, and the amp depth changes the depth of the amp envelope. So if we go to the pitch envelope, we have the envelope depth here, so how much of the signal is sent to how much of the pitch is sent to the envelope here, and the same with filter. If we go to envelope, we can send a certain amount of the filter to the envelope, and then same with the amp envelope too. Pretty straightforward. Moving forward, we've got the X mod 2. So this is effective when structure 1 to 2 or 3 and 4 is X mod 2. It applies changes to the X mod 2, 1 to 2 or 3 or 4 depth. So if you've got cross mod 2 selected, this control here changes the depth of that, and then cross mod X mod here changes the depth of the regular X mod. ATT changes the oscillator's OSC attenuator, so we can change the wave gain of the oscillator. Ring os level is, I'm just going to read this straight from the manual. This is effective if structure is ring. In the case of partial 1, changes the ring oscillator 1 level of structure. In the case of partial 2, this setting has no effect. In the case of partial 3, changes the ring oscillator 3 level of structure. In the case of partial 4, this setting has no effect. Ring os level 2, so this is effective if structure is ring. In the case of partial 1, this changes the ring oscillator 2 level of the structure. Partial 2 has no effect. In the case of partial 3, changes the ring oscillator 4 level of structure. In the case of partial 4, this setting has no effect. So if you want to change if you have your partial set to ring modulation, then this setting here will control oscillator 1 and 3. If you have it set to ring modulation, then this setting here will change the setting of oscillator 2 and 4. X mod oscillator 1 level is similar to that except cross mod. So this applies to both cross mod and cross mod 2. The oscillator 1 level will change the level of oscillator 1 and oscillator 3. And this setting here will change the oscillator level of 2 and the oscillator level of 4. Within each parameter here, we have a positive value of 63 and a negative value of 63, and 0 being obviously in the middle, so it's 127 all up. That's the definitions of them laid out, and that took a little while, but I hope that all made sense. If you know anything about synthesis, that probably made sense. And yeah, if you know more than I do, it definitely made sense. So I'm just going to reset to initial tone here. I'm just going to change it to a saw wave. We could, for instance, say, okay, let's get some pitch envelope on here. Make that a little bit shorter. We'll open up the matrix control here. So let's have pitch envelope. Let's have that now control the filter cutoff as well. But what we need to do is we need to apply some filter to it. So let's go Moog filter and bring it down to about halfway. Now the pitch envelope will also control the filter envelope. We have to remember to increase the amount. We'll increase it to full so we can really hear it. Or if we go on a negative value, it'll do the opposite of the pitch envelope. So now we'll have the pitch envelope control the, let's have it control we'll send the pitch to LFO1 and we'll remember to bring the value up. So what it's going to do is the pitch envelope, because it starts at full, because we set it here, it's going to send it's going to send the pitch to the LFO1 really drastically and then reduce it until it's non-existent when it gets to this point here. So let's just increase that a little bit, increase the decay, and let's change the LFO here to a sine wave, tempo sync. Let's have it on 1/8 notes. Just going to make that a bit shorter. We could also have it control the, let's go the pulse width. So, and we'll bring it, let's go on negative amount. So what it's going to do is over the course of this pitch envelope, because we've set it to negative in the matrix control here, it's going to start the pulse width on the oscillator here at negative, and it's going to bring it back to center. I don't think we can see it. No, we can't see it. But that's what's happening. It's just basically going like so. And let's have it also control the fat amount here. We'll bring that positive. So what it's doing with that is it's going to start the fat control up here, and then over the course of the pitch envelope, it's going to bring it all the way down. So that's sort of a pretty weird example, but you can see how powerful this can be. All right, so let's try something different. Let's just reset this here to an initial tone again. And we'll set the first one here, the first matrix control source, as CC value 28, because I know that that's the MIDI controller knob value that we did before. So we'll go 28. So now I'll have knob 28 control the cutoff. So once we set that to a positive amount, I'm just going to change the oscillator back to a saw wave. Okay, but nothing's happening when I move the knob. The reason for that is because I need to set the start point of the filter. So now at minimum value on the knob, it's going to be here, and then when I increase the knob all the way to maximum, it's going to open all the way up. So if we want to, we can bring the cutoff all the way down, and as I move, and when I play it, you won't hear anything. But as I move the knob up, now that knob is controlling the filter cutoff. Just remember, this is the start point because we've set it to a positive value. The start point is where the filter is set for that partial. So if I had that on full and I had range control, I had the cutoff on negative, Now the minimum value on my knob is going to be this, and then when I turn it up, because this is a negative value, the filter is going to go the opposite direction. So let's just have it on positive, just to keep it left is left, right is right. So now we could have that same knob controlling, let's have it control the tremolo, so the amp to LFO1, and we'll set it positive. So now as I turn the knob down, it's going to remove the LFO, and as I turn the knob up, it's going to increase the amount of the amplitude going to LFO1. If we have it in a negative value, it'll be the opposite. So when it's fully knobs all the way down, the filter's going to be all the way down, but the LFO will be maximum, and as I turn the knob up, the cutoff value is going to increase and the amplitude to LFO1 is going to decrease. No, it's not. Okay, so if we have the CC28 controlling the cutoff and also the amp envelope to LFO1, if we have it in a positive, it's going to send it positively to the LFO, and if we have it negatively, it's going to have it apply negatively. So if we know anything about LFOs, it's going to switch that to a sine wave. If I turn it up now, it's going to apply this, but if I turn it down, it's going to do the opposite of this. It's kind of a bad example. So let's again, if you know more, if you know something about synthesis, that would make sense, I guess. Let's send it to the panning. That's a good one. So we'll be able to hear that. So by the default, you're not going to hear that. But if we have it positively, as I turn the knob up, it's going to take it. Remember the default position is going to be where the partial is set. So when the knob is all the way down, it's going to be in the center. And as I turn the knob up, it's going to send it to the right. So I'm just going to remove the filter cutoff here and open the filter. So by default, and then if I turn the knob up, it's going to turn it to the right. Or if I turn it down negatively, when the knob is all the way down, it's going to be to the left. Sorry, if I have it all the way down, it's going to be in the middle, and then as I turn the knob up, it's going to send the pan to the left. So we could have that filter cutoff applying as well. So now it's going to start filtered and in the center, and then as I turn it up, it's going to open the filter and send the pan to the right. Let's just have the cutoff a little bit less, so it's not so hard to hear at the start. So we can hear what that's doing there. So let's try something crazy. Let's have the pitch envelope depth here. Let's apply some pitch envelope here. So we'll have it really drastic like we did before. So you're not going to hear anything. If we turn the depth up, I'm just going to open that filter again. But we don't want it to be like that by default. What we want to do is we want to have it so when the knob is fully open, then it applies that pitch envelope. So if we go back to range control here, pitch envelope, we turn that up. So now when the knob is all the way down, it's going to sound like that. But if we turn the knob all the way up, it's going to send it to the right. It's going to open the cutoff a little bit, and it's going to send the oscillator to the pitch envelope. Let's remove that pan. So knobs all the way down, knobs all the way open. So these examples I'm giving aren't really going to be useful together, but I'm just sort of showing you the power that you have with this. So let's go, just one more little thing here. Let's have the pitch, let's have the filter to LFO1. So when I'll turn that value all the way up, so when the knob's all the way open, it's going to send the filter to LFO1, but because we haven't applied any filter to it, nothing's going to happen. But let's bring that filter down. So I'm going to turn the knob all the way down, and as I turn the knob up, so you can hear what that's doing there. That's a better example. Yeah, so that's pretty much the matrix control section. You can have up to 4 different parameters controlling up to 4 individual other ones, either simultaneously or separately from another. You can even have CC value 28, so that same knob controlling up to 16 different things if you wanted to by setting all of these sources to CC 28. Anyway, that was convoluted, that was confusing, but hopefully you learned something from this. You can do a whole lot of different stuff with this. It's pretty crazy actually. So yeah, thanks for watching.